Okay, welcome back. This is Internal Rate of Return Part 1, Chapter 3b in Intro to Real Estate Finance. Okay, so let's think about what we mean by IRR or internal rate of return. We're going to look at this fairly briefly now, and then we're going to return to it in more depth when we look at it alongside of other discounted cash flow project evaluation methods. But right now, let's just look at this in a time value interest rate framework. Now, remember our general case discounted cash flow equation down here, which says that the total present value of all our cash flows in the future from a project is simply equal to the sum of each one of those stinking cash flows, each one individually discounted back to time t equals 0. And depending on the context, we'll say PV tot, or sometimes we'll say cash flow 0. So here's an example. Here's our PV tot, or our cash flow 0. Here's future cash flow number 1, 2, and 3. So in general, if we know the future cash flows for a project and we know PV tot or CF0, which i.e. is what we expect to get from the project, those are our future cash flows, when we expect to get those future cash flows, and what it costs us now to secure those future gets, which is CF0 or PV tot, okay? In that case, when we know the cash flows and when they happen, then R is the interest rate that makes the fundamental discounted cash flow equation true. It makes the present value of the sum of the future cash flows equal to each other, okay? Um, so in this case, we often call R, remember we've been calling our interest rate or discount rate, we often call R in this case when we know all the cash flows and when they're going to happen, but that's all we know, we call R the internal rate of return of the project or the IRR of the project. And there's a particular methodology that's used for solving for IRR that I want us to learn because it's used throughout real estate finance and finance generally. So in general, when we want to solve for a project's internal rate of return, what we're going to do is we're going to, in the discounted cash flow equation, we're going to rename R as IRR, and then we're going to rearrange terms a little bit of this equation to get 0 on the left-hand side. We're just going to move that PV tot over to the right-hand side. Okay, so we have 0 equals minus PV tot plus the sum of the individually discounted cash flows, each one individually discounted by IRR. Okay, and when we write things in this way, this is called the IRR equation. And the way to think about this is our IRR is our discount rate or interest rate that makes the sum of a project's future discounted cash flows plus our present value total equal to 0. So to simplify, IRR is the discount rate or the interest rate that makes the sum of all the project's cash flows when properly discounted equal to 0. Okay, so how does IRR help us evaluate projects? Well, we're going to use this in real estate finance very frequently, so we need to know it. First thing we'd want to do as a real estate finance professional is establish for our firm in the milieu that we're working in, development, management of cash flow producing properties, whatever, the R, the interest rate that we need to make a project worth our while. And that's going to have a particular name. We're going to call that the opportunity cost of capital. That is also used throughout finance, so you should be familiar with that. And it's usually called ROCC. Okay, so our opportunity cost of capital is the R that we need in our chosen milieu in real estate finance or finance generally to make a project worthwhile, the minimum interest rate that we can use to make a project worthwhile. Okay, so that's part of determining our strategy as a firm. So we have to do that. We have to know our financial strategy as a firm. Then when we look at an individual project, okay, we want to estimate all of the project's cash flows, including PV tote or CF0, okay? And then we're just going to use that internal rate of return equation, 74G, to solve for the internal rate of return. And we'll probably often use goal-seek to help us with this. And now if the internal rate of return, the effective interest rate for this project is greater than our opportunity cost of capital, remember that's the minimum interest rate we think makes any project worth our while. So if the internal rate of return, the effective interest rate for this project is greater than the minimum we've set as a firm operating in this area, then we want to go ahead. Okay, and if the internal rate of return of a given project we're looking at is less than or equal to our minimum, we don't want to go ahead. So that's how we use IRR in real estate finance projects, and it's also how we use IRR throughout finance generally. The sticky wicket here is establishing for our firm operating in this area what our cost of capital is. We will get to that, but that's going to be a couple chapters down the line. Um, there are problems with the internal rate of return method that have to do with the numerical problems of finding roots of a polynomial or a real equation that we've touched on previously before. But there is some good news about this. The awesome mathematicians of this world have figured out that if we have a project looking like this or looking like this, i.e., a project whose only negative cash flow happens at t equals 0 and all the others are positive, doesn't matter when they happen, doesn't matter what their magnitude is, then the IRR method is guaranteed to work. In other words, it's a little bit of a sticky wicket, but what they mean by guarantee is if we can find the smallest real root of the polynomial or the real equation, then that is the correct IRR. It's also true if we have a project whose all of the cash flows are negative except for one at the end or clearly one at the beginning, something like that, then the IRR method is guaranteed to work in the same way. If we can find the roots of our polynomial or our real equation, find the smallest real root, that's the number that we want. So that's really good. Internal rate of return is not guaranteed to work for projects like this. And sadly, this is the type of thing that we see for sponsors of development projects, as well as cash flow producing properties. If you're the sponsor, if you are the equity investor in a real estate project, you may have to invest a lot now to get stage one going. Stage one gives you some cash flow, but then you have to invest more later for phase two, and then you get more cash flow after phase one and two are complete. So sadly, this does not work well, not guaranteed to give us the right answer or possibly any answer in cases like this. So in general, for real estate sponsors, we will be using a different discounted cash flow method, not the IRR. If you notice here, these guys, they look an awful lot like the types of things that a lender would get involved in. This looks like it might be a bond or some kind of a loan where the lender gives the developer or the property manager some money and then enjoys some cash flows in return. And this looks an awful lot like it might be a borrower's perspective where they borrow for phase one, they borrow for phase two, they borrow for phase three, and then, lender again. Lends for phase one, lends for phase two, lends for phase three with something like a construction loan, and then they get paid back at the end of the project. Something like that. Okay. So lenders work with IRR all the time, including bond investors, construction lenders, mortgage lenders, etc., but not so much for equity sponsors of a project. Okay, so let's jump right into a couple of examples. Let's start with using our IRR, now that we know what it is, to evaluate an investment opportunity. So first of all, where do we stand as a firm and what's our opportunity cost of capital? So our mission in life for this firm is that we invest in very low risk, 1 or 2 year fixed income project. So we're not dealing with a real estate project right now. This is just something from general finance. Okay. And this is our mission in life. And based on that, we decide in ways that we will understand how to develop in a future chapter that any projects we pursue have to grow our money by at least 5% annually. What does that mean mathematically? That's just a way of saying in English that our opportunity cost of capital is 5%. If our effective interest rate for a project isn't going to be more than 5%, we're not interested. Okay, so we're looking for projects with this says greater than or equal to. I would say greater than, better way to frame it. We need projects with greater than 5% IRRs, interest rates, or discount rates. Okay, so that's the way we're going to work. So we know our mission in life, we know our opportunity cost of capital, then we go out and start evaluating potential investment projects. So here's one. Okay, so we have build fast developers. Happily, we can do anything that's short term like that, and we find a real estate project that fits the bill. Build fast developers offers us this deal. If we loan Build Fast 100,000 now to help them with the development of a modular housing dorm, they're going to guarantee, and this would be in the loan contract, to pay us 112,000 back in 2 years. So this will be when the dorm is occupied and our loan is exchanged for a mortgage. We don't have to worry about the exchange, but Build Fast is going to take out a mortgage to help pay this 112,000 to us. Okay, that's called flipping or converting the loan in a construction project to a cash flow producing property. All right, so now let's put this situation in terms of our IRR equation, 74G. So here's 74G. We have minus PV tote plus the sum of each individually counted discounted cash flow. Each discounted by IRR is going to add up to 0 when we've got the right IRR there. Okay, so what's the PV in this case? I'm going to grab our little typewriter tool here. Okay, and our PV in this case is 100K, and our CF2 here, whoops, where'd we go? Here's our little typewriter tool again, and our CF2 is 112K, whoop, at time equal to 2.0 years. So down here, all that I'm doing is I'm plugging that information in, okay? Um, and what you can see, one thing you should know mathematically is that this is not going to work algebraically unless we have a negative sign with the PV tote and positive signs out here, or vice versa. Okay. Um, but the way I like to think this is the investment at time t equals 0, which is minus 100, okay, plus the positive cash flow we get back at t equal 2 are the two terms we've got here. And that's how I get to the proper algebraic sign. Always consider one player at a time, okay? Her cash flow at t equals 0 is negative, and her cash flow at t equal 2 is positive. So if you always think about this in terms of one player or participant at a time, all of her cash flows, which ones are positive, which ones are negative, give the negative ones a negative sign, give the positive ones a positive sign. The signs are all going to work out for you automatically, and you don't have to worry about the negative sign here and the positive signs here. Okay, that's just me. That's the way I like to do it. Okay, um, so here we are with the internal rate of return equation with all the information for this problem built in. And how can we solve this? I hate to go back to the nightmare of high school algebra, but that's what I've got to do. Some of you will notice if we multiply both sides by 1 plus IRR squared, we'll get something a lot simpler that looks like this. Something like 100 times 1 plus IRR, the whole thing, where's my little caret? There we go, squared minus 112 equals 0. And you should definitely confirm this, right? Um, you need to be able to do this algebra. That is very important. Okay, so once we've got that, I think all of us can solve that equation for IRR. This equation up here for IRR, I'm not so sure about, but once we simplify it, I think we can do that. So the IRR is going to be the square root of 112 over 100 minus 1. And if you work that out, what I got for that is 5.8%. And I'm going to say confirm this too. You need to be able to do all of this algebra by hand with just a simple calculator. And so we have now down here, our IRR is equal to 5.8%, and that is greater than our 5.0% needed. So we definitely do want to go ahead and consider investing. We, of course, want to look at other things than just these estimated numbers, but from a basic financial point of view, looks like a go to us. Let's do another project now in Excel, and I'll bring up an Excel spreadsheet in just a second for this. So let's consider Lukoil owns the gas station in Manhattan at the corner of 24th and 10th. And they believe that they can renovate this station for 600,000, and we'll assume for the sake of simplicity, that's all going to happen immediately at t equals 0. And if they do that renovation, Lukoil has about 40 years experience in this country with various types of gas stations, so their estimates are probably pretty good. They think if they do this renovation, their estimate of what it costs is probably pretty good. That's going to result for them in after-tax cash flows positive cash flows of 195,000 per year for 10 years, starting at t equal 1. So the way it's going to work is they're going to renovate instantaneously, assuming they can do the whole thing in a nanosecond, starting right now. And then 1 year from now, after that, when all the dust has settled, for the year, they will have gotten 195,000. In year two, same thing, et cetera, et cetera, et cetera. And we assume all these payments happen at the end of the year. So the first one is at end of year one, then end of year two, et cetera, et cetera, et cetera. Okay, now how about their policy? There are 40 years of experience in this country. Using that, they have come up with their policy for gas station renovations and operations, which is that they need to generate at least 8% to make it worth their while. So what does that mean? That means their opportunity cost of capital for gas stations of this type in America is 8%. So our mission is to answer the question, is this project worthwhile? How are we going to do that? Well, we're going to find the internal rate of return of this project, the effective annual interest rate for this project. And if it's greater than the minimum required, the opportunity cost of capital of 8%, then we'll conclude they should go for it. And if not, we'll conclude that they should not. So right now, I'm going to jump to an Excel, and you should follow along in Excel and help me solve this with the Excel sheet in front of you. So I'm going to be working with this file, CH03a and 3b -tval and IRR Part1.xls, big long name, but here it is, so you can get it. And I've got here the problem unsolved, and in case you want to check anything, I've got the solution on the next page for us there. So you should at this point be able to start laying out problems like this for yourself. We've got the years of the project here. We always start at end of year 0 here. And then down here, I've got the cash flows for the project. And this first one is PV tote or CF0. And again, the way to think about this is for the player, the single participant that is Lukoil, that's a negative cash flow for them, okay? And then they're going to get 100,000 in the next 10 years. And I've got to apologize, there is a typo, big typo, in our PowerPoint here. This is not 195K. That is actually 100K here. So they think they cost them 600,000 to renovate, and then if they do that, they'll get extra after-tax free cash flows of 100,000 a year for the next 10 years. So sorry about that typo. All right, back to the spreadsheet. So what do we want to do? We're going to be working with this equation, right? The internal rate of return equation, which tells us we just want to add up all the cash flows, but we want to make sure that before we add them up, we get the present value of each one using internal rate of return to discount. So what am I going to do? I've got up here a guess at my internal rate of return. This is our methodology with goal-seek, right? You always have something you need to solve for. Algebraically, it might be a nightmare. And so what you're going to do with goal-seek is you're going to guess at that thing you need to solve for and use goal-seek to help us hone in on what exactly that number should be. So I'm going to just take a guess, any old guess at the IRR here. And now that I've got that, I can discount each one of these back to t equals 0. It's not going to do me any harm to discount this one happening at t equals 0, or PV tote. So what's our general way of doing this? You all should know this by now. It's the cash flow itself divided by 1 plus the discount rate or the interest rate that we are thinking about. And I'm going to put dollar signs there to lock that down. And then that's going to be raised to the number of periods that we need to discount that back to t equal 0. Okay, all right. I think that is a very nice looking general formula. Um, and one nice quick way you can check to see if your discounting formulas are correct is you can make your interest rate equal to 0. If your interest rate, discount rate, is equal to 0, the time value of money is equal to 0. So the present value of all your cash flows is just equal to the cash flow themselves. So that's a good way to check that formula. I'm going to put my 8% guess back in here. And down here, I have already filled in for us what I want the sum of all of these, just like we have in the equation up here. I want to include that cash flow at t equals 0, okay? And I want to include all the future cash flows discounted, so I'm adding them up. I'm adding C15 to M15. I've got the right row here, and I got 71. What does the IRR equation tell me? I need this to add up to not 71, but 0. How am I going to make that happen? Well, by using better and better guesses for IRR. I go to 9%, I get down to 41. I go to 12%, I have negative 35. So I want to be a little lower here. I go to 11%. And this again is where if you have a sacrificial intern, in my case, someone working at my firm, or a sacrificial mentee, maybe in your case, you could ask them to do this for you manually, keep them out of your hair for an hour or two. But the quicker way to do this is to go ahead and use goal seek. So we go to data what if analysis, goal seek, and we need to set that set of all the present value cash flows for the project to our value of 0 by changing what? By changing our guess at the IRR. So blammo, there we are. And here we have a nice 0. All these guys have added up to 0. And what makes them add up to 0 are 10.6% internal rate of return. Okay, so that's our IRR. So now let's think about this a little bit. I want to go back to our little PowerPoint here, and the opportunity cost of capital is only 8%. The effective annualized interest rate for this project is 10.6%, so they should definitely go ahead and do it. So here's our 10.6%. Our IRR of 10.6% is greater than our opportunity cost of capital of 8%. So they should go for it. And very shortly, you'll be asked to go for it too in homework covering material very much like this. And so to help get you started with the homework, I'm going to say enough of the bullshit talk from me and say, for now, sayonara.